our last section for Module A, we're going to talk about order of operations. This comes from section 1.8. In order to do this section, we want to know how to combine, meaning add and subtract, multiply, and divide integers. Upon completing this presentation, you'll be able to understand the order of operations and why we simplify expressions using this order. You will also be able to simplify a variety of expressions using order of operations. So one of the ways to remember order of operations is PEMDAS, if you like speaking gibberish, or you can also use please excuse my dear Aunt Sally. Most of us probably know one of these, but let's go ahead and talk about this in a little bit more detail. P stands for parentheses. Now, parentheses can mean a variety of things. Our basic definition when we talk about parentheses means anything inside something else. So when we say inside, what we mean is we want to simplify inside. You can simplify inside parentheses, absolute value bars, square roots, numerators, denominators, and as you go through math, this list can get longer. Our second operation that we have is exponents. Also included in this section is roots, absolute value, and again, as you proceed through your math class, you will have this list also grow. Now, when we talk about the difference between parentheses and exponents, you'll notice that some of these things show up several times. Absolute value bar is there a couple times, square roots are there. And so the difference is the first step you want to simplify inside. The second step you want to do is to evaluate. So just to give you a quick example of what I mean by that, let's look at the following. If I say the square root of 25 minus 9. The first thing that I want to do is I want to simplify inside the square root. So I want to combine 25 minus 9, giving me square root of 16. This here counts as my parenthesis step. My next step is to evaluate the square root, and the square root of 16 is equal to 4. This counts as my exponent step. So that's one thing to keep an eye out for when we talk about these things. From there, we have multiplication and division. One thing to note with multiplication and division must be done from left to right. If you note here, down at the bottom, must be done from left to right. Meaning if you have a division that appears before a multiplication, then you must perform the division before the multiplication. We'll talk about this in more detail as far as why is that. Addition and subtraction, you have the same rule. This must also be done from left to right. But this one doesn't get us in as much trouble because remember that we no longer think of subtraction as subtract. We think of it as being a negative. So let's talk about why is that. Just like when we add and subtract sign numbers, we keep the sign with its number. Similarly, with multiplying and dividing, the operation applies only to the number after it. So, for example, if I have something like 20 minus 5 plus 4, there's a couple different things that we can do in order to simplify this. One of the things that we can do is we can combine 20 and 4 and get 24 minus 5. This results in 19. Now remember, if you do decide to combine the negative 5 and the 4, remember that you have to keep the sign with the 5. This is going to be 20 minus 1 equals 19. You can also go from left to right. So if we start with 20 minus 5, we get 15 plus 4 equals 19. So the important thing to remember is that just like with our addition and subtraction, we need to remember that that minus goes with only the 5. The same thing applies when we talk about multiplication and division. If I change this to 20 divided by 5 times 4, I need to remember that this 5 here has to be divided. So what we need to do is we can do one of two things on this one. If you want, the easiest way to do this is to go ahead and do the division first. 20 divided by 5 is 4 times 4. We get 16. You can also do kind of what we did when we looked at the first method up here. If you want to combine the 20 and the 4, you can go ahead and multiply 20 and 4 to get you 80 and divide that by 5. If we do that, we still get 16. The only thing that you cannot do is you can't do divide by 5 and multiply by 4. You cannot combine those two things together. If we do that, we get 20 divided by 20. Basically, what you're saying is you want to divide by 5 and by 4, and that would be incorrect because we do get 1. And notice that that is not the same thing as what we got in the previous examples. And so no matter how you do this, you should still get the same answer. So the main thing to remember in this section, or one of the main things to remember in this section, is that you do need to remember that multiplication and division must be done from left to right. This is a hint, 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 because this is one of the things that I do like to quiz you on quite a bit, and hopefully by the end of this semester you will understand it. So now let's talk about why do we organize the operations like this. Let's start at the bottom. If you think about when we worked with the poker chips, addition is a shorthand method of counting. Subtraction is the opposite of addition. It involves counting how many remain after removing a certain number of objects. So at the bottom we have addition and subtraction. If you go one up from that, you have multiplication and division. Multiplication represents repeated addition, and division is the opposite of multiplication. Similarly, exponents represent repeated multiplication. And so that's why we organize our exponents, multiplication and addition, division and subtraction along there as well, the way that we have it there. Exponents represent repeated multiplication, so let's work on those first, and then expand it out. Addition or multiplication represents repeated addition. So basically if we expand it out, then we only have addition. So that's one of the reasons that we have it like that. Now, where do parentheses fit in the mix? Well, parentheses are used if we want to perform a lower operation before a higher operation. Sometimes we may want to add or subtract before we multiply. And the only way that we can do that is using parentheses. So hopefully that makes a little bit more sense in terms of our order of operations. So now let's go ahead and look at some examples. We want to simplify the following problems using order of operations. Now, one of the nice things about order of operations and the Please Excuse My Dear Aunt Sally is it does give you a checklist off to the side that you can go ahead and mark off as you go through a problem. So let's go ahead and look at some of these and see what we can do. If we look at A, we have 18 plus 2 times 3 minus 10. So the first thing that I want is I'm going to go ahead and write down my note here. We have, please excuse my dear Aunt Sally. So the first thing I want to do is go through. Do we have parentheses in the problem? We do not. So I'm going to cross it out. We can consider that step done. We don't have exponents, so I can go ahead and cross that one off. That step is done. And so the first thing that we have is we can do multiplication and division. Remember, we do want to think of that as basically one operation from left to right. So multiplication, we do have a multiplication here. We have 2 times 3. So I want to multiply those two numbers together, and I'm going to bring down everything else in the problem. So now what we have is 18 plus 6 minus 10. That takes care of multiplication and division. My next step is additions and subtractions. We can do these from left to right, or remember that as long as you remember minus means a negative and we're adding, you can combine these in any way that you want. I'm going to go ahead and start with 18 plus 6 gives me 24, minus 10 gives me 14, and we're done. Okay, so that takes care of the first problem. Let's go ahead and move on to example B. Example B, we have 6 squared minus 24 divided by 2 squared times 3 minus 1. So if we have our little note to ourselves, we have please excuse, and I'm going to say that a better way to write it may look something like this, having the multiply and divide on one line and the add and subtract on another, just to make it, just to kind of remind yourself that multiplication and division needs to be done at the same time, similarly with addition and subtraction. So let's go ahead and see what we can do on this problem. So if I look at my checklist, my first step is parentheses. Since we don't have any parentheses, I can go ahead and check that off. My second step is exponents. So I want to calculate the 6 squared. 6 squared, remember, is 6 times 6 will give me 36, minus, I'm going to bring down the 24 because we don't need it yet. 2 squared is 4, 2 times 2 is 4, times 3 minus 1. So that takes care of my exponents. So now the next question is, what should we do in terms of our multiplication and division? Now this problem is kind of tricky because if you forget the rule and you decide to multiply before you divide, you will get a nice answer. So I consider this kind of a trick question. If you get to the point where if you do your multiplication and division in the wrong order and you start having to rely on a calculator, you can't do it without a calculator or without having to get pencil and paper out and start doing some long division. That is an automatic warning sign that something went wrong. All of these you should be able to do in your head. You should not have to use a calculator. You should not have decimals. You shouldn't have any kind of weird fractions. They should all come out nicely. But as I said, this is a trick one, and so we do need to remember our rule for multiplication and division. It needs to be done from left to right. So I'm going to go ahead and divide 24 by 4. That gives me 6. I can now go ahead and multiply 6 times 3, which will give me 18. And as I do these steps, note that I keep bringing down everything that I am not using as I continue. From there, we can go ahead and subtract. So this, it does not matter which one you do first. For instance, you can do 36 minus 18 is 18 minus 1. If you want, you can combine negative 18 and negative 1 to give you negative 19. They have same sign, so we're going to add and keep the sign. And then now if we subtract 36 minus 19, we get 17. If you had done 36 minus 18, again, you would have gotten 18 minus 1 is 17. We will get the same answer no matter what, if we do it correctly. Okay, let's look at the last two for this section, or for this slide. We have C. We have parentheses 2 times 5 squared. So, on this one, if we follow our order of operations, the first thing that we want to do is parentheses. I want to simplify inside parentheses. So 2 times 5 is 10. That gives us 10 squared. And now if we simplify the exponent, we get 10 squared is 100. And you're done. Now if you look at C versus D, the only difference between these two problems is one of them is inside parentheses and one is not. So how big of a difference is it going to be with parentheses versus no parentheses? Well, if we look at D, what's the first thing that we need to do? Since we have no parentheses, the first thing that I need to do is exponents. I want to square just the 5. 5 squared is 25. And then now if we go ahead and multiply, 2 times 25 is equal to 50. So note that just parentheses alone can make a huge difference in our answers. Okay, so these are some basic ones that we have. And now we're going to go over and look at some more complicated ones. All right, the next set of examples are going to be a little bit more involved. Now, for example E and example F, one thing to note is square brackets have no special meaning. If you think about working with Microsoft Excel, if you use parentheses, multiple sets of parentheses, they color coordinate them. Well, in math, we don't have color coordination because we're just not that cool. So what we do is we alternate between square brackets and parentheses. parentheses go with parentheses, square brackets go with square brackets. So when we look at example E, the first thing that we want to do is we want to simplify inside the brackets. But here's the thing. Inside the brackets, we also need to follow order of operations. So in order to simplify inside the brackets, I need to start by simplifying inside the parentheses. So my first step is going to be 4 minus 7 gives me negative 3. From there, to simplify inside the brackets, I don't have to worry about exponents, but we do have multiplication. So I'm going to multiply 5 times negative 3 next, and bring down everything else. So we get negative 15 plus 9. My next step is going to be addition and subtraction. We can add negative 15 plus 9, and we get 2 times negative 6. Now, if you don't like the square brackets, what you can do is you can go ahead and use parentheses. Because remember, square brackets, that's all it means, is another way to write parentheses. So now we're down to our last step. We want to do 2 times negative 6, gives us negative 12. And we're done. So let's go down to problem F. Problem F, again, we want to start by simplifying inside the brackets. And again, in order to simplify inside the brackets, I want to start by simplifying inside the parentheses. So I'm going to subtract 8 minus 2, combine 8 and negative 10, and I'm going to bring down everything else. So we have 18 divided by 6 plus 4, square bracket, 5 plus 2, we said 8 and negative 10 combined to negative 2 cubed. Our next step is exponents. Again, we're inside the brackets. So I want to evaluate negative 2 cubed, and I'm going to bring down everything else. We get negative 2 cubed is negative 2 times negative 2 is 4, times 1 more negative 2 is negative 8. From there, we can multiply inside the brackets, and we get 18 divided by 6 plus 4 bracket 5. 2 and negative 8 combined to negative 16. You can either write that as plus negative 16 or just minus 16. From there, we want to go ahead and subtract inside the brackets or combine inside the brackets. And we get 18 divided by 6 plus 4. Again, if you want to change it back to a parenthesis, you can. We get negative 11. Since we have a positive 5 and a negative 16, those are different signs. We want to subtract, keep the sign of the larger number. Now, from here, we're now back to the larger problem. So, from here, what we want to do is our divisions and our multiplications. We get 18 divided by 6 is 3, and 4 times negative 11 is negative 44. you can either write that as plus negative 44 or minus 44. We can now go ahead and do our additions and subtractions. We get 3 minus 44 is negative 41. Again, you have a positive 3 and a negative 44. We want to subtract, keep the sign of the larger number. And that finishes off the problem. Now, one thing I do want to point out on this one is over here, did we have to wait until the very end to do 18 divided by 6? And the answer is no. The more familiar you become with these, then you can start getting into combining different operations. You do have to be careful though. If you went ahead and combined 18 divided by 6 in the beginning, you do need to be careful and make sure that you don't try to add 3 and 4 in the next step. When you start combining operations, you need to look at either side of the number. And here what I'm talking about is the 4. When I look at 4, I need to know, can I combine it with the 3? Or do I need to multiply first? Since multiply first does come, or since multiplication does come before addition in our order of operations, then we do need to go ahead and finish simplifying inside the brackets before we can multiply by the 3 or add the 3. If you have more questions on this, please make sure to ask in class and we can look at some more examples of this. But just make sure that when you are doing order of operations, it's always best to take more steps, make it a little longer, until you become more comfortable and can recognize when you can combine operations. All right, the last example we want to look at is example G. This is another problem that involves parentheses that don't necessarily look like parentheses. Here we have numerators and denominators. So the first thing that we want to do on this problem is we want to simplify the numerator and we want to simplify the denominator. If you want, you can do these simultaneously. Think of this as this is going to be kind of a typical multitasking problem. So what I want to do is I want to look at the numerator first. What's the first thing we need to do in the numerator? Well, the first thing is the parentheses. So I want to combine 3 and negative 12. And if we do that, we get 2 times negative 9 plus, can I multiply 6 times 4 right now? Yes, you can. Because if we leave it as 6 times 4, it doesn't matter. We're going to multiply it later anyway. I'm going to go ahead and leave it alone for now, just to be on the safe side. So that takes care of the numerator. So now let's go down to the denominator and see what we can do there. On the denominator, the first thing we want to do is exponents. Now, be very careful because in the last section, remember that we talked about negatives being inside and not inside parentheses. Note that there is no parentheses here. The negative is not inside parentheses, which means that the exponent is not acting on the negative. So we want to know what is 2 to the 4th. Well, 2 times 2 is 4. Times 2 is 8, that's 3 of them. Times 2 is 16. And we keep the negative. Remember, it's not inside the van. It's not going to the store. We're going to bring down the plus 1. Okay, so now that takes care of our first step on the numerator and the denominator. So let's go back to the numerator and see what we can do now. Now we can go ahead and multiply, do our multiplications. So we get 2 times -9 is -18. 6 times 4 is 24. Note that it wouldn't have mattered whether we had done it in this step or if we had done it in the first step. We still would have gotten the same answer. Okay, so that takes care of the numerator. In the denominator, we can combine -16 and +1. Since they are different signs, we're going to subtract and keep the sign of the larger number. We get -15. All right, let's go back to the numerator now. If we go back to the numerator, we get -18 plus 24. We have different signs, so we're going to subtract, keep the sign of the larger number, which is the 24 on this one, and then our denominator is still -15. Now we want to go ahead and bring the problem together. We've simplified the numerator, we've simplified the denominator, and so now I want to go ahead and simplify the fraction. We cannot divide this evenly, but we can simplify the fraction. Both of them are divisible by 3, leaving me with 2 over 5, and I'm going to go ahead and move the negative up to the top just because it looks a little bit nicer there. So our final answer is -2 over 5. And that takes care of some of the more complicated examples. Again, the more steps you take, the better off you are, the less likely you are to make mistakes. This concludes our basics of factoring. Note that factoring, we will see this throughout the semester. The first place that we are going to see it is later in this section when we get to part 4 of 8.2. We will apply basics of factoring when we talk about simplifying fractions. We will expand the concepts of listing out all factors when we discuss factoring polynomials in Chapter 6. And we will expand the concepts of listing out prime factors and prime factorization when we discuss simplifying radicals in Chapter 8. So when will we see this again? Order of operations will be fundamental whenever working with problems that have more than one operation. We will see this throughout the course. We will use order of operations again when we talk about evaluating expressions and working with formulas. We will expand the concept when working with simplifying expressions, solving equations, rules of exponents, and simplifying polynomials. Now that you've gone ahead and watched the lecture, try the following problems on your own and bring them as well as any questions that you might have to class. One of the key things to remember in this section is the rule for multiplying and dividing from left to right. That is one of my favorite questions to put on exams. The other one is anything involving negatives and exponents, and knowing the difference between when your answer is positive and when it is negative.